Welcome to part 2 of our exclusive tour of Pulsar Fusion's facilities in Milton Keynes in the UK. In our previous episode, we got introduced to Pulsar Fusion's main product, that is to say, Hall effect thrusters, or ion engines is another thing to call them. And their idea behind this is to sell conventional engines and conventional technology, which is directly related to the next generation propulsion that they're working on putting into space for its first test in 2028. But we also, I'm sure, want to get introduced to the main product that Pulsar Fusion intends to sell soon, which is a fusion propulsion system. Now, this is different than fusion power. It is fusion propulsion. What's the difference? Well, first of all, if you haven't seen part 1 of this tour, then I recommend you stop this video right now and go here, and the link is also in the description to check out part 1. But if you want to get up close and personal with Pulsar Fusion's plans for revolutionizing space travel, along with some of the other products that they make in order to pay the bills in the meantime, well, hang on, we're going to be going back to Milton Keynes and Pulsar Fusion in just a moment. Okay, so my understanding of Pulsar is you're kind of like a threefold company in terms of what you have to offer. Mm-hmm. You have the Hall effect thrusters, which we've been talking about. You have fusion that you're working on in the long term, but you also have these hybrid rocket engines. Tell me about these. I mean, what makes these different?
Yeah, hybrid rocket engines, super interesting technology. So I think most of your viewers are familiar with rocket fuels. They tend to be two liquids get injected into a combustion chamber and they react. Hybrids are called hybrids because one of the fuel components is actually a solid.
Right.
And fuel always consists of two things, a fuel and an oxidizer. So in the case of these hybrids, the fuel is actually plastic. It's actually high-density polyethylene. It's very unfancy. It's literally a cylinder of the same plastic that we make milk bottles out of.
Wow.
Nothing elaborate at all. So they're extremely chemically stable and insensitive things that you can store without any concern about them suddenly going bang.
Right.
And the way you ignite these things is you heat up the HDPE just with a simple pyrotechnic charge, and you blast in some oxygen, and you just start a very messy smoky fire. And once it's up to temperature, you then switch to the oxidizer, which is nitrous oxide.
Right.
So if you like your Fast and Furious movies, it's the thing that people put in their cars to make them go faster.
Right.
Also known as laughing gas. You blast that into the other end, and then it properly ignites, and you end up producing thrust. And I have here a piece of fuel grain. This is actually fuel grain that's previously been burnt, and so don't know whether you can see, but the inside is all charred and eaten away there, and it's lost maybe 5 millimeters of plastic on the diameter there. So this is a previous firing that we've had. We actually had these X-ray scanned, and you can see those on our Instagram channel. We had these X-ray scanned to understand the exact burn rate. Really fascinating stuff.
So, of course, people concerned about the environment are going to say, my God, you're burning plastic. I mean, it's so polluting and all that. But could you put, some people have talked about putting recycled plastic as a component. Are you thinking about doing that?
Yeah, 100%. You could easily use recycled plastic. So there's some degree of green credentials to that, depending on depending on where the plastics come from, I suppose.
Right, right.
But yeah, we definitely look at that.
So what is the, tell me about the advantages then of putting a mixture of solid and liquid versus two liquids.
Yeah, no problem. So the biggest advantage, I suppose, to hybrids beyond more conventional rocket engines is that chemical insensitivity. Plastic doesn't explode normally. It's very difficult to ignite.
Right.
And so if you were storing these somewhere, you really wouldn't have to worry too much about them going bang. This is the big advantage to a hybrid rocket project. If anything, they're a little bit temperamental because lighting them takes a bit more work than other types of rocket fuel.
Fantastic. So that means you can deliver these engines partially fueled, right? And then all you have to do is pump in the oxidizer.
Absolutely right, yeah. And in fact, the mechanism for pumping in the oxidizer and the oxygen is standing behind me on this platform.
Wow. So if you're about to fire this up, show me this here real quick. I don't know if that's exactly what you use, but yeah. Is this how we make this work?
Absolutely. So this is our control panel for our fuel feed system here. And you can see our fuel feed system is actually mounted on a conventional trailer. We did that mainly because we like to set ourselves very hard problems. And we know that building a fuel feed system is more complex than building the rocket engine for a hybrid usually. And we thought it would be interesting to see, well, let's make life difficult for ourselves. Let's put it on a mobile base so that weight becomes a factor as well. And this is the control system we built for it. So all this does is controls the flow of both oxygen and nitrous oxide into the rocket engine.
Gotcha. Okay, so you got nitrous there, oxygen there.
Yeah, the one marked,
stuff.
It's really fun, yeah, the one marked ignition is just an electrical switch which will activate a small pyrotechnic device inside the engine, and that's what provides the initial heat to begin the burning process. And if you guys have seen any of the footage of us testing this thing, you'll see it in a beautiful snowy background in Switzerland. You'll see this plume of black smoke coming out for a few seconds before it ignites. That's when we're in the oxygen burning stage, where all we're doing is trying to raise the temperature of the plastic to a temperature that it then becomes possible to burn nitrous oxide.
Now, as far as I understand, you're also looking at liquid hydrogen and oxygen solution as well. Tell me about where you're headed with that and what sort of advantages that might have.
Well, we like liquid hydrogen for many reasons. One is that when you burn hydrogen and oxygen, you end up with simply water vapor, right. Which is obviously environmentally beneficial. The problem is, where do you get the hydrogen from? This is still, people have been building hydrogen rockets for decades, of course, but nevertheless, the sourcing of the hydrogen so that there's a proper hydrogen economy is one of the main roadblocks to this becoming a widespread launch tech.
All right, so we had a brief look at this last time I was here, but there's a 3D printer, is that correct? Can you explain what you do with this?
Sure, this item is not a 3D printer, it's actually a 3-axis milling machine.
Okay.
A milling machine is, picture a drill bit, but instead of cutting by drilling down, it cuts by digging sideways into the workpiece. And this thing can move that drill bit or milling bit in 3 different axes, so X, Y, and also Z. And so it gives us a huge amount of control for fabricating all sorts of different components. So this machine can cut all types of metals, steel, aluminium, but it can also be used for cutting ceramics, things like graphite or boron nitride.
So take me through your manufacturing process, then your assembly process, because Rich told me that you guys have sold actually quite a lot, or at least you have orders for quite a lot of Hall effect thrusters right now. So how do you go about making these for the customer?
Sure, it's a big process, because as you can imagine, you're building something that has to be exquisitely built to very fine tolerances and also deliver outstanding performance. So we start, of course, with CAD models of everything. We start by talking to the customer, figuring out what they need. Our engineers sit down and design a product for them, or we might have a product sitting on the shelves already ready to go. But very often there'll be a little bit of design work to tweak an existing product for their needs. Then we will fabricate a prototype and deliver that to the customer so that they can actually have it in their hands, make sure that they're happy with how it attaches to the spacecraft, interfaces with their computers and all that. And then we can move forwards to developing a full flight model and they can take delivery of a finished product. But we take the quality of our fabrication and machining extremely seriously. So that's why we do a lot of our fabrication in-house now, to make sure that we can tightly control the finished quality of what we hand to the customer.
So tell me a little bit about your competitive edge, because again, Rich kind of alluded to the fact that you can work with a wide variety of customers, all kinds of different satellite buses, that sort of thing, whereas other engines are specifically designed for specific customers. So how can you, I guess, have a broader base of appeal?
Sure. We see a lot of inflexibility in the space hardware industry right now. So a lot of companies that build space hardware, whether it's propulsion systems or anything else, they have their product, they're happy with their product, and that's what they want to sell you. Whereas Pulsar, we are consummately obsessed with quality engineering. So if a customer comes to us and says, guys, I quite like this, but it needs to be smaller or lighter, or our satellite is an unusual design and it needs to fit in this thing that's difficult to do, we love to hear that. That is very much our bread and butter. We love solving those very awkward integration problems, which everyone has, because there is a real lack of standardization in the space industry.
Okay, so Rich obviously was extremely excited also about this big vacuum chamber. I mean, this is where the big work is going to take place. So please take us through this process and what this means for your company and your long-term objectives.
Absolutely. So as you know, Pulsar's mission has always been, let's establish a revenue stream, and then when we have that in place, let's go after fusion propulsion, because that's what we see as being the really big prize in space propulsion. And the chamber we're standing in front of is our first step along the path to fusion propulsion. Now, we're in the process of designing a linear fusion propulsion system that will take hydrogen plasma and it will heat it using a technology very similar to what you would find in a microwave oven. It will heat it to fusion temperatures and then allow it to exit one end of the system to produce thrust. So in this system, the point of this vacuum chamber is to test the heating process. That's mainly what we perceive to be one of several key technical challenges in designing this system, is how do you actually reliably heat a plasma to 100, 200 million degrees centigrade so that
200 million.
Exactly. How do you get it up to those fusion temperatures reliably in a system that isn't going to break? Because of course, you're looking at very long duration missions, right? Nobody builds a propulsion system like this for something that's going to be in space 3 years. No, it needs to function for 10, 15 years, or very long projects. So we need to make sure that we can build something that can reliably heat a plasma to those temperatures reliably.
And so here's the end result of what Pulsar Fusion is trying to accomplish, not to create fusion power, but just to create plasma, utilizing deuterium and helium-3, very much in the same way as you would start a fusion reaction, but you don't need to get energy out of it. All you need to do is generate the plasma, because the plasma itself is first of all ionized, and secondly highly energized, and if you can control it, contain it, and direct it by use of an electromagnetic field, that exhaust, or the plasma leaving the rocket engine, is going to be traveling as fast as 350 kilometers per second. 350, as opposed to 4.5 kilometers per second for a conventional rocket engine. Therefore, you're looking at something more than 70 times as efficient as a rocket engine. So Pulsar Fusion is going to be making this plasma in the laboratory in their facility with an insane amount of power. They showed me 3 step-up transformers that they have in their facility, which will convert the energy that's already coming into the lab into a colossal amount of energy, which will be able to create that plasma. Not the same plasma that you would get out of the types of fusion reactions that they create in other laboratories, but nevertheless, it will be enough in order to prove the concept and to prove that the principle that they're working with is going to be valid. So once this is successful, and assuming that it is, what's the next step? How many steps do you have to go through before we're talking about an orbital test?
We're quite ambitious when it comes to orbital tests. We think that there's little point in building ground level concepts when you ultimately want to fly it in space.
Right.
So we're really keen to get going on an in-orbit demonstration in the next couple of years. So what we'll do, once the heating demonstration is successful, we'd look to do an in-orbit demonstration of that technology 2 or 3 years afterwards.
My God, that's soon.
Fast,
I mean,
yeah.
Really, that's
absolutely.
Incredibly ambitious.
We don't want to mess about with and be slow.
And my understanding is the plasma is easier to control in microgravity as well, and in vacuum and all that. Is that, well, obviously it's in vacuum already, but microgravity, it's an easier thing to control?
It's a little easier, not because of the absence of gravity, but because of the absence of air in space. So if you look at a lot of conventional fusion reactor designs, they tend to use maybe 30% of the energy they produce just to run vacuum pumps to keep air out of them, where of course you don't have to do that if you're in space. Also, cooling your superconducting magnets might be a little easier if you're facing the cold vacuum of space as well.
So, okay, let's, I'm going to take this right to the core of what you're trying to achieve here and see if you're willing to make a big statement. Let's say that this works. Let's say you do your on orbit and it works as perfectly as you want to. Have you at that point then revolutionized space travel?
Absolutely. If you have something working in space the way you want it to, then space exploration has changed.
Well, I can't wait for you to revolutionize space travel then. James, thank you so much for your time
Thank
today.
you so much.
Really appreciate it, and all the best.
You too.
And by the way, I'm going to be free to cover these events as they happen. So excited for this opportunity. But Richard Dinan, CEO of Pulsar, had one more warning to pass on before the tour was complete. So a hot topic right now, which we've discussed earlier today, Rich, is the whole issue of deregulation. You know, a lot of anger directed towards the CAA, the FAA, and others in terms of, you know, some people are arguing we need to have less regulation and greater freedom to experiment. Can you tell me how you feel about that and how less regulation might affect you?
Yeah, I think, as you say, companies like ours are constantly going to be trying to push to get more red tape cut. I think that's obviously something we want, and that's the sad truth about why people don't launch anything in the UK is it's so hard to get any clearance in the UK. And I think that does need to be looked at because the US are so far ahead of the UK, and that I think our regulation is holding the United Kingdom back for sure. The US, on the other hand, I think have been amazing in letting these companies really progress. I think one of our worries is that if someone gets it wrong and does something absolutely catastrophic by accident, it will set the whole sector back because suddenly everyone, regulation would really be increased. So I think it's very important for companies to appreciate, in a way, the freedom we have to innovate and the responsibility that comes with that. To make sure that we are really, looking out for it's a medium between the regulators have got to be allowed to do their job, but at the same time, there's got to be that happy medium of innovation must also have that freedom. I think the other thing that people is a sort of a delicate mix is about funding. In this new interest rate environment, rates now at 5% at the time of this interview, there's not that many people chucking huge numbers at tech companies. And that's a change, especially for fusion. Will people keep rolling these fusion companies with zero revenue when rates are, at a all-time high since 2007, and we've got these companies that have huge burn rates. And one of the things I've been thinking about recently is it's not, achieving fusion burn, as we call it, is a really important milestone, but we've also got to watch out for our fusion burn rate, if you forgive that expression, because if we are burning huge amounts of money operating big facilities and lots of people on the payroll and no consideration towards having an income, I think that could be a problem for fusion. So that's why companies that are actually selling products right now, I think learning to be able to make to sell products at the same time as doing your research is so important, and it's a good discipline because you're listening to people rather than deciding what you think they want and hoping that they'll buy it off you. And I think that's certainly something that we've been focusing on.
Well, an intriguing perspective indeed. So yeah, I never really considered until we talked today that if something were to happen, if a particular mission over in the U.S. were to go catastrophically wrong with injuries or God forbid deaths, that sort of thing, you think that it could have a very negative impact on the whole sector, especially folks over here. They say, God forbid, we don't want to have that happen here in Britain, and so they stop you completely. Is that what you're saying?
Well, I think there is still a freedom. We have that freedom to innovate and build these companies with, we have to apply for licenses to launch things, but if there was, some kind of big accident, as you say, God forbid, I think it could make the regulation go very far the other way, and that would completely stifle innovation. So there's got to be a point in the middle. I think America probably have it right. I think England need to cut a lot of red tape still, but so I do see the both sides of it.
So the reason that I came out here for 2 days, and the reason we've invested so much time in this place and in this company, is because of what they're trying to accomplish here. As we said before, revolutionizing space travel, and in all the reporting that I've been doing about this, and it's been actually caught on by a number of other media companies. They've noticed what's going on here, and they've reported on it as well. There are many people who have thought that all of this is just a bunch of fancy CGI and no substance. There are many people who have made comments on my videos in the past that they don't even think any of this is true, that it's some kind of fraud or some kind of hoax in order to secure funding, grants, whatever. And so I wanted to come here in person to show you all of the amazing developments, the amazing progress that this company has made in less than a year, all of the Hall effect thrusters that they've sold, over 200 of them thus far, so many new customers that they've acquired, and the fantastic business model based on the idea of selling 2 different products that work, that are very useful to spaceflight companies, satellite companies, etc. right now, and earning the necessary cash flow in order to make fusion propulsion possible in the future. And I'll tell you something, this company is for real, and I can't wait to see what they do next. And that's one of the big reasons, by the way, that I live right here in Milton Keynes. So until next time, guys, I urge all of you to stay angry about space.